Next, I'd like to discuss Johnson's rule, which is a pretty neat little optimization algorithm that can minimize the total time of completing two tasks or set jobs. Let's assume that we've got two partners who are gardeners. One person rakes, and once the raking is completed, then the next person mows the grass. And what we'd like to do is figure out, we've got 6 yards, we'd like to figure out which order to rake and then mow to minimize the total time to complete both tasks. Okay, so we're first going to rake, then we're going to mow. Okay, so we've got 6 yards, and these are the times here in minutes. Raking yard 1, for example, takes 30 minutes. Mowing yard 1 takes 90 minutes, and so on. And I'm going to write the sequence of the events down here. Number 1 would be what the jobs that we're going to complete first, second, third, fourth, fifth, and sixth in that order. Okay, Johnson's rule works like this. You look at all the times on both columns, and the one that's minimum is the one that we assign first. Okay, the 15 is the lowest time, and notice that that's on the first list of the raking. So we'll put a check there under 4, and we'll put that job first at the beginning of the list. So that's job 4. So if it's on the first list, then we put it at the beginning of the list. If it's on the second column, second job, the lowest, then we put it at the end. So, okay, what's next? It appears that we've got a tie. 30 for raking is tied with 30 for mowing. So, yard 1 is on the first list, on the front of the list. Yard 6 is on the end. So check those out. Next is 40. So that's at the beginning of the list. We can check that off. Okay. And then we've got a bunch of ties. 45, 45, 45. So let's break the tie by looking at the 45 to 60. So 3 would be next, and then 2 after that. Okay. So again, if the lowest was on the second column, we put that at the end. If it was on the first column, we put it at the beginning. So the sequence of jobs, we first rake yard 1, then yard 4, then yard 1, then yard 5, then 3, then 2, and finally 6. So how long does it take to complete all those jobs? Well, let's look at this Gantt chart here. So we start raking on yard number 4, and we complete it at time 15. Then yard 1, and so on. 4, 1, 5, 3, 2, 6. We complete the raking at 280. We can't mow until we've completed raking. So for mowing, we're idle for the first 15 minutes. That's when we can start job 4 that's completed at 15. First rake, then mow. We complete that at 75. Then we can start right away on 1. Then we can start right away on 5. Note that it has to be completed before we can start it. And in some cases, you might have some idle time in there. But the general idea is you put the short jobs at the end, and the short ones for the first process you put at the beginning so you can get started on them right away. So what we end up with is a total time to complete both jobs is 345 minutes, sequence in that order to minimize that total time right there, the 345. That's what Johnson's rule does for us.